Hello all, my name is Sid. Welcome to this video tutorial about SQL injection labs. So today we are going to talk about the challenge 4 and what are the objectives of challenge 4 and how can you solve challenge 4. So just to give you a little background, my name is Sid. I'm one of the founders of Not So Secure Limited. Right, so once you sign up for the SQL injection labs, you will be given a set of questions. Each question will have, you will be given a question paper sheet. In the question paper sheet, you will have a number of challenges. Currently, there are 20 challenges in the SQL injection lab. Each challenge has a unique URL, and that challenge may have one or more objectives. So for example, today we are looking at challenge number 4. So in challenge 4, the URL is this, and this URL has this challenge has these objectives. So there are 6 objectives. Okay, that's something I need to tackle here. Okay, so the objectives here are identify the parameter vulnerable to SQL injection, how many columns are returned in original SQL statement, what is database version, what is username for database user, provide a URL which lists all table from backend database, and finally, what is the value of the flag stored in table secret. Okay, so when you sign up, you will be given a set of VPN credentials, and you don't need to download anything. The VPN is a PPTP VPN, so you can use the Windows built-in client and connect to the VPN with your credentials. So I'm just going to connect to the VPN. The password is already saved in my computer, so I just click on connect, and this is it. I am now on the SQLi Lab VPN. So if I now copy this URL and paste it in my browser, I can access that challenge. Okay, that's because I was using burp and I had shut down burp, so I'll just remove Foxy proxy from here, and if I now access that URL, I'm straight into the SQL injection challenge. So challenge number 4 is a simple SQL injection challenge. We've rated it as a basic challenge. So it's an employee search form. You search for job titles. You can search for database admins. You click on submit, and it displays you the data from the backend database. In this case, you can pretty much assume that the query, which is probably running on the backend database, will look something like this. Select star from employees where job underscore title is equal to the value which you insert. In this case happens to be database administrator. So this is just a simple pseudocode, what you would expect the application to do. Now if we need to investigate this application for SQL injection, we can start playing with this URL parameter called job title. So if we inject a single quote into it, what we see is the query does not return any results, which is interesting. Now we can start playing with this parameter and say if it is vulnerable to SQL injection. So we know that the comment character in MySQL is hyphen space. So if we inject hyphen space, okay, let's just do this. Hyphen plus is the URL encoded space. Then you can see we get the same results back. Some other tests we can do. Hash is also a comment character for MySQL databases. So, but just when you inject a hash through the URL, you just need to be careful, and you need to URL encode the hash, because browsers interpret hash in a different way, and it may not send the hash character onto the backend server. So just make sure you URL encode hash, and hash is always %23. So these tests kind of confirm that it may be prone to SQL injection. Some other cases which we can throw at it, single quote and 1 equal to 1 hyphen space. This returns true again. You can see the same output on the screen. If we do and 1 equal to 2, it does not return any results. That's because perhaps the SQL now looks something like this. Select star from employees where job title is equal to database administrator. You've injected a single quote, and then you injected and 1 equal to 2 hyphen space. So this last quote character has now been commented out, and the final query is essentially this: select star from employees where job title is equal to database administrator and 1 equal to 2. Because you've injected an AND clause, in the right hand side of the AND clause is a false condition, the overall query now evaluates as false, hence you don't see any results being displayed onto the screen. But if you do AND 1 equal to 1, the right hand side is true and you see items displayed onto the screen. If you inject OR 1 equal to 1, then that obviously short circuits the entire logic of the query, and basically the where clause do not hold any meaning anymore, because there is an OR clause and the right hand side of the OR clause is a condition which is always true. So that's also one way to confirm that it is actually vulnerable to SQL injection. So in this particular case, what we are going to do is use the union technique, because we can see that the result of the SQL query is displayed onto the screen. So we may be able to use the union injection to extract data from the backend database. So the way union query works is so if you are injecting, say, union select null -- space. Okay, if you are selecting if you're injecting union into an SQL statement, then you have to take into account that the query which you have injected after union must balance with the query which was originally there. So we need to be able to balance whatever we are injecting via union with the original query. So we need to know in the original SQL statement how many columns and how many columns are returned by the original query. So for example, over here, if it is star, we don't know how many columns the original query had. So one way to enumerate how many columns the original query had, we can start injecting the order by clause. So what order by does, it sorts or it orders the results by a particular column name or column number. So if we do order by 1 and we inject this in the original query, in the SQL, in the URL, then you will find that order by 1 returns some records. Order by 2, let's inject order by 2, again returns some records. So which means that there are at least 2 columns in the original query. Order by 3 does not return any records. So there is a good possibility that the original queries had 2 columns which are returned in the SQL statement. So if we do a quick test and try to inject union select null comma null, that will kind of confirm sorry, let's just copy this part here. So as you can see here, this query has not returned any errors. In fact, there is an additional line which is basically a null line or a blank line which is being returned from the backend database, showing that our query is now fully balanced and we are in a position to pull out data from the backend database. Now we need to find out, we've identified that there are 2 columns in the original query. What we do not know is what are their respective data types. Like I said, the query which we've injected via union must balance with the original query in the which the application was issuing. So we now know that there are 2 columns, but we don't know what are their data types. Now null is one data type which matches multiple data types. So you can select a null for an integer. You can also select null for varchar. You may also be able to select null for a blob. Now what we need to do is we need to identify if any of these fields which are being returned onto the screen is a varchar, and if we can identify one of those 2 columns, if any of them happens to be a varchar, then we can get the output of our injected query through that varchar. So we're going to play with say last field here, and instead of selecting null, let's just select a static string called AAA just for the sake of selecting it. And you can see that this record set, which was selecting a static string, is now being displayed onto the screen. Okay, so coming back to the question's objectives, identify the parameter vulnerable to SQL injection. We've identified that job title is vulnerable to SQL injection. The second objective was how many columns are returned in original SQL statement. We verified that there were 2 columns returned. We now know that the second column is a varchar because we were able to select the second a static string in the second column. We don't know about the first column, and honestly we don't care because one column which is returning varchar is enough for us. Okay, so the next objective is what is the database version. So now instead of selecting a static string, we can select a function which returns a varchar. This is a MySQL server. So if we issue the query select version or union select null comma version, then you can see this is the MySQL version. So that answers the question, or that answers the objective for what is the database version. The next objective is what is the username for database user. So we can change this version query to the user query or a user function, and we can see that the username is 4 at localhost. That might be corresponding to the SQL4. It might be a small hint. Okay, next question. Provide the URL which lists all tables from backend database. Now, in case of MySQL, there is a table which contains the metadata about the database, and that table is called information_schema.columns. And this table have table name called table_name. If I can spell things, life will be so much easier. There is also a column called column_name. So because we can use maybe the first column to select table name and second column to select column name, or we can just use the one column and use the concat function which is built in the table in the MySQL database, and select the values for both these columns, table name and column name, using the concat function. Okay, when you do that, obviously they will be concatenated and you will not be able to separate where the table name ends and where the column name starts. So just to make it more readable, we will select a static string --, which will basically be a separator between table name and column name. So all we now need to do is select this field from information_schema.columns. So we copy this. Now in the first column, union select null will remain as it is. Now instead of selecting a static function, we select a field which is concat table name static string comma column name, and we select this field from this table called information_schema.columns, and this should display all the table names stored in the backend database. So you can see the first entry is the table name followed by a static separator --, followed by the column name. So the table called character sets have a column called character set name. Similarly, character sets also have another column called default collat name, and so on and so forth. So as you can see, this is a massive, by injecting this one union query, we can dump the entire database schema. Okay, so we now know all the tables and their corresponding columns for each table. Now let's go back to the question. It says provide the URL which lists all tables from backend database. So the answer to that would be this URL. Next it says what is the value of the flag stored in the table secret. So we know, I mean, the hint in this question is that there is a table called secret. So first of all, we need to find out what are the columns in the table called secret. So now that we've listed all the tables, we can just search for table called secret, and we can see that there is a table there called secret and it has a column called data. So now instead of selecting concat this from information schema tables, what we can do is we can select from secret, and the column name would be data. So once we execute that, then we are selecting data from secret, and we can see that the table secret had this entry called well done, flag is 66529, and that will be the answer for the last question. So that is a little video walkthrough for challenge 4. Next we will discuss challenge 5. For now, thank you so much.